From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan, announcing show number 205, recorded live Thursday, March 11th, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks OData with Pablo Castro.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. Today we've got Pablo Castro, who's a principal architect at Microsoft, and one of my favorite people, because he works on one of my favorite products. And that product is changing a little bit, and I wanted to bring Pablo on the show and talk about it. Thanks for taking the time to sit down with me.
Hey, Scott. Yeah, sure.
So let's start at the beginning, because I'm a little confused. Some people are confused. There's this thing called the Open Data Protocol, or OData. And if you go to odata.org, there's a very basic web page that explains a lot about this thing. But then there was a thing called ADO.NET Data Services that you can go file new item in Visual Studio. And then there was a thing that was codenamed Astoria. Can you reconcile these three things for me, please?
Oh, absolutely. So at the beginning, there was a project Astoria. And that was an experiment. And, we give experiments code names because we don't know what we're going to do with them. People liked it, so we turned it into a product. And since we don't do cool names as a matter of policy, we changed the Astoria name into ADO.NET Data Services, which sort of matches the team where the technology sits, and it aligns with other components in the stack. And we did with that for a while. Now, one of the things that happened while we were trying to get used to, say, ADO.NET Data Services is that the protocol used by ADO.NET Data Services sort of took a life of its own. People started to implement it, sometimes using our toolkit, sometimes without. And we saw a lot of value on the protocol itself. It was an enabler for applications to share data and all that. And it became a thing of its own, independent from effectively what is our .NET implementation. So we decided to give the protocol a name, and we debated this a lot, and we ended up calling it the Open Data Protocol, or OData. And so now we have the protocol, and we of course have a .NET implementation. And we realized that we were doing a lot of work to align the Astoria stack with WCF. We already do some, but we wanted to go further. And this setup is actually very similar to what we already do in other contexts. Like if you look at our SOAP stack, we have SOAP, that is a protocol, and we have the WCF implementation, that is the .NET implementation of the SOAP stack. So we thought it would be a good idea to do the same thing, and this sets up us for the long run. So what we have now is the Open Data Protocol, and that's a protocol. So it's a document, if you will, that describes what to do. And then we have WCF Data Services, which is the .NET implementation of it. And you can expect other implementations of OData to pop out there over time that are independent from WCF Data Services.
Okay, so let me see if I understand then. So Astoria was an early code name. ADO.NET Data Services was the thing that we called it when we put out .NET 3.5 Service Pack 1.
Yep.
And then it became kind of a thing of its own, specifically the protocol, the angle brackets and the model, the data model. Then you put the protocol out into the world and you released it basically like in an open specification.
Exactly.
And then now what we thought of as ADO.NET Data Services is the Microsoft implementation of OData. And are we calling the Microsoft implementation of OData something different than ADO.NET Data Services?
Yeah. So starting with 4.0, we're starting to call it the WCF Data Services.
WCF Data Services.
Yeah.
Okay, but it's all the same.
Yes. No new products introduced.
Okay.
Just a mess of names.
So that means if I already have one of these, I have an open data endpoint.
Great.
Is that correct?
Yeah. So
Is that what I would call that? If I have an ADO.NET data service now and I'm using it in my product, can I tell people I have an open data endpoint?
Absolutely. You have an OData service.
I have an OData service. Okay. I assume that as principal architect, you have no control over the actual name that some marketing guy decided.
Yeah, that's a fair assumption. I'd like to think that I can influence a little bit, but as you can tell, I failed miserably. So yeah, I think it's a fair take.
Okay, so give us a little bit of a basics of how this works. I'm reasonably familiar with it, but kind of walk me through the stack. Is this talking to the database, or is this talking to some objects? What interfaces do those objects have to have? And can kind of walk me from the inside out.
Got it. So the protocol doesn't dictate anything about where the data comes from or how you process it. It's entirely described in terms of the edge, like the interface itself. So you can think of it as what you see when you talk to a server over HTTP. And it really doesn't get into the business of how you manage that data. If you look at actual implementations, in particular, if you look at our .NET implementation, the way this works is we have an abstraction that is the usual provider model thing, where we since the system is heavily declarative, the abstraction is very centered around metadata. So what you do is you describe the shape of your data set somehow, and the somehow could be you give us a bunch of .NET types and you tell us that each type represents the shape of a particular data item, or there is a more generic way of describing the shape of your data using a few classes that you can think of them as sort of the reflection classes, except that they're independent from .NET types. So you can give us a description of your data even if you don't have .NET types for them. So once you give us a description of what the data looks like, we will automatically construct the URL namespace, all the serialization formats, and all of that for you. The second question, though, is that's metadata. Where does the data come from? That, again, is up to the implementation. And in the case of the .NET implementation, what we did is we needed something that was very flexible, didn't impose any particular data model constraints in it. And it turns out that the link framework that was kicking around back then, it was like a new thing. It's a perfect abstraction for that because it has the idea of an iQueryable, so you can formulate a query. But the shape of the query and the shape of the results are very flexible. They're not constrained into a particular model. So the way we did it in our framework is we actually the abstraction that separates the provider from Astoria is just is a query object. So the Astoria runtime, whenever I say Astoria, you can replace in your mind and put the right.
Yeah, it's interesting because you're still calling it that in your mind as well.
Oh yeah. But you can replace it with the corporate compliant name as you go.
Well, as long as we all can agree as a group that it's all the same thing, I think that's what's important, and it is, and that's comforting.
Yeah. Yep. So the framework simply, whenever we get a URL, we think of a URL as a query. And we translate it into a query object and then hand it out to the provider. And then you can use any queryable implementation or create your own to hit the data source. And the data source, it may be a relational database. And in that case, you never write your own iQueryable. You use one that already exists. You can use the entity framework. You can use, there is a link translator for Hibernate or whatever you want to use. Or you can write link translators for custom things, and we see a lot of people doing that. They write sort of very relatively narrow specific translators for custom backends, and then it's up to you to run the query, give us the results, and then we'll handle the serialization and such. So basically, the separation of responsibilities is the data services framework will handle all the HTTP head, all the URLs, serialization, all the interaction models. There's a few details of HTTP that we don't want everybody to have to deal with, so we handle all that, and the data source gives us a way of figuring out the shape of it, gives us a way of figuring out or give us a way of querying for the data, and if they want to, they give us a way to update data back into the data source.
Okay, so if I want to make one of these and I don't want my database underneath it, I implement iQueryable, and if I want to support updating, I implement iUpdatable. and that's all I need to do. I mean, if my object or my database or my data source implements iQueryable completely, then I can make it an OData endpoint, no problem.
Yeah. There is a little bit of a dance you have to do to hook it up, but if you already have an iQueryable, the rest is really, really a little bit of incremental work. Like a great example of this is, starting with the 2010 version, all of the SharePoint sites are OData servers. So if you have any SharePoint site kicking around, if the administrator deploys the option to or the package to have data services on it, all of the SharePoint data is OData.
Okay.
So the way that happened is the SharePoint guys have a link provider or a link translator that they already built. They use for other things as well. That it goes against SharePoint, against the SharePoint's. You can think of it as a link translator on top of SharePoint's business logic layer. And the way they use data services is they simply give us the root of their queries as their own iQueryable implementation, and data services does the HTTP business, and then SharePoint continues to do their business logic stuff. And there's very, very little sort of code that goes beyond this like strong separation layer that is the query interface.
So they didn't have to do a lot of work then. I mean, really, their underlying data source didn't change. The way that they think about things didn't change. It's just that rather than navigating it with a browser, you're navigating it with the OData model.
Exactly. And they got to preserve their business logic, which is it's, one of the key aspects of data services and OData in general as a protocol to bear in mind is like OData is not the thing you use to sort of create a shortcut into the database, like a gateway type of thing. It's, sometimes you want to do that. If you have, for example, reference information you want to just publish, then sure, you can put an OData head on a database and share it. But oftentimes on something like SharePoint that has custom access control, the updates have a lot of constraints in them and things like that. You actually want OData to expose data as seen through your business logic, not as your store. And I think SharePoint is a perfect example on how to imagine that. SharePoint has all these options around who can do what and, all these workflows and all these things. And the OData head has to be on top of that, not on top of the underlying store.
Okay, so what happens if SharePoint needs to, throw some kind of important business exception or let me know about something that OData as a protocol doesn't support?
So SharePoint, any implementation for that matter, you can stop at any point and throw an exception. And if you usually what happens is the inner parts of the system throw exceptions that are specific to their business logic, and then usually in your OData, or actually in this case in the data services provider logic, you catch those, and then there is a special exception called data service exception that lets you indicate the actual message, which you usually get from the underlying exception, and also you can give us an HTTP status code, so we can report a proper status code to the client. One of the things we do, and we're very picky about, is we try hard to be very good HTTP citizens. So we encourage all of the folks implementing these things to do proper translation of specific error messages to something that maps reasonably to HTTP errors when it's possible.
Hi, this is Scott Hanselman from another parallel universe. Got to tell you about some of our things our sponsors are doing. They make this free podcast possible. If you're developing a new line of business application, you've probably tried the latest version of Silverlight. Now you can get even better results by combining the functionality in Silverlight 4 Beta with some of the richness of the third-party controls from our friends at Telerik. They're the first vendors to offer native support for the Silverlight 4 Beta and their rad controls. They've got a new Silverlight 4 CTP suite of these controls. They let you tap into the framework's great potential. You got native right mouse click and all the new features of Silverlight. There's 38 controls that give you all these features. You can start building those compelling line of business applications right away. I encourage you to check those products out at telerik.com/Silverlight. And, thank Telerik for supporting .NET Rocks, supporting Hansel Minutes on their Facebook fan page at facebook.com/Telerik. Now back to the show.
So this is interesting because this brings up the concept of REST. I mean, you're saying that OData and the OData spec and your implementation of it tries to use HTTP, I would say, as the envelope, right? I mean, with SOAP, HTTP was secondary and the envelope was something that was part of the body of the HTTP message. But with OData, if there's an existing error code in the spec that maps to what you're trying to do, then you'll use that. That starts getting into the kind of the REST philosophy of things, which is, embrace our transport, in this case, HTTP. Is that fair to say? But how does that make OData, is OData a REST style, interface, or is it something else?
Yeah. So, I guess to answer your first question, yes, we try, I would say one of the main guiding principles around the design of data services and OData in general is do not invent stuff. And I think the whole team has sort of gotten that mantra, and they are all used now to look hard around before you come up with anything new. And that includes all of the HTTP protocol. We use a lot of it. In fact, I'm surprised to look back and see how much of it we were able to leverage. There is a lot in the HTTP protocol that was a very, very natural fit for OData, spanning from error codes to actually very nice things like e-tags for concurrency control and things like that. So yeah, we use it extensively. As for the REST question, loosely speaking, I think yes, you can say OData is a RESTful system in the sense that it's very centered around state and resources, and for the most part, the protocol does not include custom operations. The protocol is very centered around the idea of a uniform interface, which is the other core concept of RESTful systems, together with resources. And also, every resource in the system gets an address. When you put this together, it means that the uniform interface gives you the ability to perform this uniform actions on top of all of the resources by using URLs to talk about them. And that is many of the elements that are characteristic of RESTful systems. So I think in that sense, it's fair to say there is it lines up fairly well with RESTful systems. There is a few things that we push a little bit further. Like, for example, good RESTful systems are hypermedia driven. And what that means is, you send a document to a client, and the client, the only thing it does is it renders the document or presents the document using its knowledge of MIME types, and then it follows links to the next action. So the document contains the links to the next things or the next set of documents you can go see. OData does heavy use of links, so you can actually do that, and every document you get the links to the related items and things like that. But we also have a URL convention that people that want to use can choose to use, and that allows you to formulate simple queries and things like that. Having on the client knowledge of the server URLs is controversial at least, and it sort of doesn't fit well with the hypermedia centric approach. So there's folks that would prefer to opt out of that, and we designed the protocol so you can opt out of it. But if you opt into it, then you have a fairly RESTful protocol for the most part, and you have this bit that introduces extra functionality, but it bypasses the hypermedia constraint.
When I hit an OData endpoint with my browser, it immediately thinks that it's a feed, and I get the feed-friendly view inside of Internet Explorer, and I have to go in and tell Internet Explorer, don't stop doing that. Basically, I don't think that you're a feed. I want to see reality. So then I turn off friendly feed view, and I see the actual markup. And just like you said, you see you get a particular item, you see a URL to the next related item, and then you can navigate to it. And it's usually a copy-paste kind of an operation. It feels like you're navigating the web with Telnet. If you ever tried that, that's an experiment that I do in some of the classes that I used to teach in university. I basically make people open up Telnet into port 80, and then surf the web, and it's kind of the same thing. Do you anticipate, or has it already happened, like OData specific browsers, or making browsers recognize OData so that it could be presented in a way that would allow me to navigate more naturally?
Absolutely. There's actually several efforts to do that, and they range from developer tools, like for example, folks that work with Link may be familiar with LinkPad, which is available out there. It's not a Microsoft thing; it's a couple of folks building it, and the LinkPad, as of a few months ago, actually supports OData, so you can point LinkPad to an OData endpoint and actually browse around with it.
Really? Wow, I love LinkPad.
Yeah, well, now it's a native OData speaker. So we're also cooking up a couple internally, and actually we're packaging one of them as an example. We'll probably ship it pretty soon, so people can play with it, modify it, and stuff. But yeah, I definitely expect OData explorers to start to pop up. I expect a spectrum of them, from very simple ones that just browse around and maybe follow links, to sophisticated ones that can actually change data if they, handle authentication and all that stuff, provided the server allows it.
So that brings up an interesting point. I think there's kind of two classes of OData services. There's the, basically slap the implementation of OData on top of an iQueryable. This is the very, very basic step zero. And I think that's what I see the majority of. And then there's extending OData in appropriate ways, like, of course, making it updatable, but also making service operations available. Mm-hmm. And I've been working on extending an application to include OData, and myself and John Galloway, who's working on it with me, and yourself, kind of had some discussions where we would think that, here's a perfect place for an operation. And by an operation, I mean not navigating in the standard way, but like it's almost like an operation in OData as an extension method. It's like, look, here. Yep. And each time you would kind of say, no, you don't need that because you can get to that data the regular way. Mm-hmm. Is that common? That we keep? It's almost like saying, hey, we need a stored procedure here. And you say, no, you can do the query like this, and then suddenly you don't need a stored procedure. Do you find that there are fewer and fewer needs for this service operation? And maybe you could say a little something about service operations.
Yeah, well, as you know, I tend to push back on service operations until they're really, really needed. The problem with service operations is one of the really, really good things about HTTP and in particular RESTful systems on top of HTTP is the idea of a uniform interface. Uniform interface means everybody agrees on on the meaning of the operations you do. So when you do a GET, the web works because of this. Like when you do an HTTP GET to get a resource from, say, a web page or something, like oftentimes a proxy or some other kind of intermediary will actually answer on behalf of the server without even talking to the server. And that actually is done without second-guessing anything. The protocol clearly defines whether or not that is okay to do or not, when you can cache, when you can reply on behalf of the server, and all that. So the ability to have intermediaries requires that intermediaries, clients, and servers have agreement on the meaning of the operations. And that means that the operations have to be well known. So the uniform interface is exactly the list of operations that everybody agrees on. So we all know that GET is or hopefully there's always something broken, but in principle, GET, if you do a GET against a URL, that's a non-side effecting operation, and modulo headers to control caching, it's usually safe to cache the thing, it's idempotent, so it's safe to replay it and all that. So you know all those characteristics. Similarly, we know that if you do input, that is certainly a side effecting operation. And so, you can't, for example, you may not be able to cache the response, for example, or you're not supposed to blindly replay it just in case. It may not be idempotent, or post in particular is a good example of that. So service operations break the uniform interface. They introduce a name of an operation that is opaque to everybody. So unless you know about the implementation on that server, you don't know the characteristics of that operation. Is it read-only? Is it side-effecting or not? Is it idempotent? No, you don't know. So the only thing you can do is either you can guess and it's dangerous, or you can assume the worst and then never cache it, never help anybody, have the intermediaries blindly pass it around, and so on. So this is kind of geeking around on HTTP, but it actually is important to build good scalable systems. So the reality, though, is that the resource-centric abstraction sometimes just runs out of gas. And, you can still represent certain things, but it gets weird. And, doing things very, very weird only on principle sometimes is just, inflicting pain without a real gain. So service operations are a way in data services to say, well, if things got really, really weird and you want to have a custom entry point, here's how you do it. At least we'll do it all the same way, so we agree on how you do it. There is some use cases for service operations that are great. A couple of examples are One is pure computation. Like if you're doing like a calculator function or something, those are very weird to do as resources and state transition. It's much better to just have a function that does something. The other one is when you want to have kind of views over the data, and sometimes the view has a filtering criteria or a way of sorting or something that you just can't express easily in a URL because it's complicated or because it will require you to send too much data or something. And it's just easier to pass a few parameters to a function and get the results back. And I think in that sense, I think it's just a matter of being pragmatic and balancing principles with getting the job done.
With OData, we're using, for the most part, if I understand correctly, angle brackets across the wire, unless we're talking to JavaScript, and then it will automatically speak JSON. It'll speak JavaScript object notation. Mm-hmm. Is there can I speak an even more terse format? Can I have it speak binary XML?
So not today. That's the short answer. This is a topic that I care about a lot, though. There is this is a tricky thing where you have to balance, the interoperability with efficiency requirements and such. So right now there's no binary XML support. So your options today are you can use JSON. JSON is a smaller payload than the Atom or XML format that we use. Although it has less fidelity because the JSON literals are not enough to cover the typical data sets that we manage. So what I've seen people being successful at today is they've been using just HTTP compression. XML compresses really well, and you're trading it for CPU, but the trade-off works well, and I've seen people being successful at this. So if you turn on compression, you'll see a huge reduction in bandwidth utilization.
Right, and this is actually a good example of doing HTTP and embracing HTTP. It's part of the spec, and it will squish. Yeah. It'll squish something like 40-50%.
Yeah. Sometimes more. I mean, XML is a great thing to compress because you can feel very proud of yourself very quickly. So yes, and this is plain HTTP. There is a content encoding header. You can negotiate, and clients negotiate whether or not they can handle compression. So the same endpoint can serve both clients that can and clients that cannot handle compression. And we're looking at binary XML. I really care about binary XML. The only problem is even choosing a binary XML format is controversial. So, this is a topic that we need to spend some time figuring out what is the right thing and how do we do it and how to make sure it's interoperable, and all that. So I think there's just a bunch of open questions, but it's certainly a topic we're looking at.
Well, this is, and I was actually headed in a certain direction, and I think you can probably guess that, which is in the 90s, I was thinking about COM Plus, and we thought about COM in the context of, hey, look, here's an object, and it was in process, and oh, look, now it's out of process, and I have location transparency. I don't even need to think about that. And when you would go from object orientation to distributed applications, a lot of times people would keep pushing the concept that, look, there's location transparency. And then service orientation introduced some formalization to that to say it's not reasonable to take an object and suddenly take it from in process and put it in New Zealand. I need to know that object and accessing its data has a cost. So service orientation kind of formalized that. But all the while, I felt like Microsoft hasn't really embraced any kind of prescriptive guidance around multi-tiered systems. Is OData, is our OData implementation the kind of the ideal way to make a 2-tier CRUD system now a 3-tier CRUD system?
I think the generalization is too dangerous. Okay. I don't think it's general enough for people to use it as a rule. So the reality is that you have to think a little bit about the nature of the interaction between the upper half of your application and the bottom half, sort of what is going to become the front end of the app and what's going to become the middle tier. And you have to think about whether you can truly express all the interactions in terms of resources. If you can, then data services will save you a lot of work. And in the process, it'll also give you a middle tier that has a lot of goodies. It can be accessed by other applications. it's interoperable. Any client out there can talk to it, and all the standard, I'm going to call it the OData pitch. So there's a bunch of benefits to it, but the interaction model has to work for you. There are scenarios where you want a more operations-centric interface that is more constrained, and sometimes being able to constraining the interface so it does less and it's more domain-specific, it's more specific to what you're trying to do. It's actually a great feature because it adds to predictability. In general, it has a very crisp boundary on what the application can and cannot do. And in that case, I think the right thing to do is to use WCF and create a more operations-centric interface and not a resource-centric interface. So, I think once you can make a call on whether you are going for an operations-centric abstraction or you're comfortable with resource-centric, then the decision is straightforward. If you're heavily resource-centric, then you can use data services. If you want to do a bunch of operations, then we have WCF, which has extensive support for sort of SOA type systems and an operation-centric service interface in it.
So it seems like if you that very, very commonly people would have both. I mean, you'd have WCF data services for the resource-centric aspects of things, and then for the more formal things that are operations that would have different requirements, you would use WCF proper and what I think of as WS star.
Yeah, exactly.
And they would live side by side. I mean, there's no reason they can't be in the same application, I suppose.
Yeah, we see that a lot. People use the two services together a lot. And in fact, that's part of the reason why we are, we didn't just change the branding of data services. We're actually, working to aligning the technologies because we see our customers using them together so often that we think there is value in having deeper integration between the stacks. We have some already, but we haven't gone far enough, and that's why people have to have two. And so we're exploring how we can do that better. And it depends on the type of the apps, but applications that are more like traditional multi-tier apps do tend to have both. We want to help there as well.
So to make sure I get my names right, WCF services and WCS data services are different things. WCS data services is now what we're calling our implementation of OData. And then WCF services are the services that I'm familiar with already.
Mm-hmm.
All right. Well, thanks so much for sitting down with me today and explaining all of this. I really appreciate it. And I suppose we'll hear some cool stuff at Mix about OData as well?
Oh, absolutely. So Mix next week, and we'll have a bunch of news. So watch the blogs, watch the keynotes. We have a lot to say at Mix about OData.
And definitely, of course, check out odata.org. And
absolutely.
Yes. Lots of stuff up there as well.
Yes, you can expect actually an actual site. You mentioned that the site was kind of low end right now, which is the case.
Yes.
So starting next week, definitely check out odata.org. You'll actually see a website that looks like a website there.
Very cool. Well, thank you, Pablo Castro, for sitting down with me today and explaining OData.
Great. Thanks, Scott.
This has been another episode of Hansel Minutes, and I'll see you again next week.